Hey guys, Mr. G here. In this video, we're going to take a look at graphing trigonomic functions. Now, in order to graph trig functions, we're going to be using the unit circle. Graphing trig function is a similar process to graphing any type of function, whether it's linear, quadratic, cubic, square root. We always need a table of values or x and y table, and we need to pick a certain kind of values to plug in into a given equation, which in this case are the trigonomic functions. Now, for this video, we're just going to be taking a look at two kind of trig functions, which are sine and cosine. So let's start off with graphing y equals 2 sine of x. All right. So I'm going to be using the unit circle to help us graph this given function. Now, if we take a look over here, we see on the x-axis we have the degrees labeled out. And we're only taking a look at the quadrantal angle measurements, degree-wise and radian-wise. All right, and there's going to be a reason for that as we graph y equals the sine of x. Now let's go ahead and use the unit circle. All right. Now we have our unit circle, and if you guys recall, when we evaluate sine of a given degree or radian, we always look at the y value of the intersecting point of the terminal side of the angle and the unit circle. All right. So we're going to start off with 0 degrees. And at 0 degrees, we're at 1, 0. All right. So if I were to evaluate sine of 0 degrees, that would be 0. So we have sine of 0 degrees, which is 0. So that's my output for sine of 0. So now I'm going to move in a counterclockwise direction. So then we're at 30 degrees, and sine of 30 degrees is the y value of that coordinate, which is a half. Then we move on to sine of 45 degrees. Sine of 45 degrees is root 2 over 2. Then 60 degrees. Sine of 60 degrees is root 3 over 2. And then we move on to 90 degrees, and sine of 90 degrees is 1. So from 0 to 90 degrees, each of the y values are increasing. All right? So the outputs for sine from 0 to 90 degrees are increasing. All right? So I'm going to go ahead and use that to start graphing this one. So we're starting off with 0 degrees. So if I were to plug in 0 into this equation, sine of 0 degrees is just 0. So I start off with 0, 0. And then I work my way up. And at 90 degrees, sine of 90 degrees is 1. All right? So now I'm going to try to continue on with the graph from 90 to 180 degrees. So I'm going to go back to the unit circle. All right? So now we're going to go from 90 to 180 degrees. All right? So we have 90, and if you recall, sine of 90 is 1. So now I'm going to continue rotating in counterclockwise. So we're at 120. Sine of 120 is root 3 over 2. Then we have 135. Sine of 135 is root 2 over 2. Then we have sine of 150. Sine of 150 is a half. And then we're at 180. And sine of 180 is 0. So from 90 degrees to 180 degrees, the outputs are decreasing. So we're going from 1 to root 3 over 2 to root 2 over 2 all the way until 0. All right? So from 90 to 180, my graph is going to be decreasing from 1 to 0. All right? So I'm drawing the graph, and it's going down to 0. So I have 180, 0. All right? So far I have half of the graph. And now we're going to continue on from 180 to 270 with my unit circle. All right? So let me move this up. So now we're going to rotate from 180 to 270 degrees. So we're at 180 degrees. That sine of 180 is 0. And then we move on from 180 to 210. Let me just move it over here. We have sine of 210, which is negative a half. Then we have 225. Sine of 225 is negative root 2 over 2. Then we have 240. Oh. Sine of 240 is negative root 3 over 2. And then we're at 270. And sine of 270 is negative 1. So from 180 to 270, each output values are decreasing. So we're going from 0 all the way until negative 1. All right. So for my graph, I'm going to go ahead and draw my graph. So from 180 to 270, the graph is decreasing. All right. So for this graph, we're over here. And if we take a look, we see that from 180 to 270, my graph is further decreasing up until negative 1. All right. So now I'm going to go ahead and figure out my graph from 270 to 360. So if I were to rotate the unit circle counterclockwise from so sine of 270 is negative 1. Sine of 300 is negative root 3 over 2. Sine of 315 is negative root 2 over 2. Sine of 330 is negative 1/2. And then sine of 360 degrees is 0. So from 270 to 360 degrees, the outputs are increasing. All right. So from 270 to 360 degrees, the graph is going to be increasing from negative 1 to 0. All right. So I'm going to go up. And we see that I have my graph for sine of x from 0 degrees to 360 degrees. All right. So now what I want to do for this graph is label the characteristics. All right. So if we were to take a look, we see that we have these 2 points, which are the highest and the lowest point. So this over here is going to be my maximum. All right. And then this over here is going to be my minimum. All right. What else? And then now I'm going to fill in my x and y table for this specific graph. So we started off with 0, 0. So I have 0, 0. And then we have 90, 1. If we were to evaluate sine of 90 degrees, my output would be a 1. And then we have 180 degrees. Sine of 180 degrees is 0. Then 270. Sine of 270 is negative 1. And then we have 360 degrees. Sine of 360 degrees is 0. All right. So this is going to be my table of values for sine of x. And we're going to be sticky with these degrees and radians when graphing trig functions, specifically sine and cosine. All right. So now I'm going to go ahead and graph my cosine function. So we have y equals to cosine of x. Let me go ahead and highlight this. So we have y equals to cosine of x, and we're going to be using the unit circle to help us graph this function. All right. So starting off with 0 degrees. Remember, whenever we evaluate cosine of theta or theta, we usually look at the x-coordinate of the intersecting point of the terminal side and the unit circle. All right. So when we're rotating counterclockwise, the output is going to be the x-coordinate. So starting at 0 degrees, cosine of 0 degrees, move it up, cosine of 0 degrees, we see that my x-coordinate is 1. So cosine of 0 is 1. All right, so I'm going to move in a counterclockwise direction. Cosine of 30 degrees is root 3 over 2. Cosine of 45 degrees is root 2 over 2. Cosine of 60 degrees is 1/2. And cosine of 90 degrees is 0. So for the output values for cosine, we see that we're going from 1 to 0, all right? So the outputs are decreasing. So for y of cosine, I start off at 0, 1, and then my graph is going to be decreasing from 0 to 90 degrees. So once I hit 90 degrees, I'm at 0. All right, so let's start off filling in the table. So we have cosine of 0 degrees starting off. We get 1. And then cosine of 90 degrees, we get 0. All right, so let's go ahead and continue on with the graph by using the unit circle. All right, so with the unit circle, I'm going from 90 to 180 degrees. All right, so cosine of 90 is 0. Then we have cosine of 120. Cosine of 120 is -1/2. Then we have cosine of 135. Cosine of 135 is -√2/2. Then we have cosine of 150. Cosine of 150 is -√3/2. And then we have cosine of 180. And cosine of 180 is -1. So for the output values for cosine, we're going from 0 all the way until -1. All right, so my graph for cosine is going to be further decreasing from 0 to -1. All right, so I'm going to be drawing my graph, and we're stopping at -1. All right, so if we were so for my next point on the graph, I have 180 as my input, and cosine of 180 would be -1. All right, so moving on. All right, so let's go ahead and further rotate the circle, or in this, rotate the terminal side of the angle. So we're going from 180 to 210, and cosine of 210 is -√3/2. Then we're at 225. Cosine of 225 is -√2/2. Then cosine of 240. Cosine of 240 is -1/2. And then we're at cosine of 270. And cosine of 270 is 0. So for each output for cosine, we're going from -1 all the way until 0. So now my output is increasing. All right, so from 180 to 270, the graph is going to increase. So I'm gonna go up to 270. I'm at 0. So filling in the table, cosine of 270 degrees would be 0. All right, so now we're almost done. Now we got to go from 270 to 360 degrees. All right. So we have cosine of 270, which is still 0. So 270 to 300, we have 1/2. 315, we have √2/2. 330, we have √3/2. And 360, we're back at 1. All right. So from 270 to 360 degrees, the output for cosine goes from 0 all the way until 1. So my graph is further increasing for the outputs. So from 270 to 360, it's further increasing until 1. All right. So for my table of values, cosine of 360 is 1. All right. And if we were to identify the characteristics of this graph, we see that this point is my minimum. All right. And then these 2 points are my maximum. All right. So we have our graph for sine and cosine. Now what I want to do is further point out the characteristics for the two graphs. Now when pointing out the characteristics, we have these terms for graphs of trigonometric functions. starting with the midline. So the midline is a horizontal center line where half of the function is above and half of the other graph is below it. All right. So with midline, it's kind of like on the middle part of the graph. So if we were to kind of like eyeball the graph and see where it would cut in half, that's the midline. All right. Now, if we need to calculate where the midline is at, we would use this formula. So we have y equals to max plus the min. So those, we use the output values. So the y values for the maximum point and the minimum point of the graph. And then after we add them, we divide it by 2, or in some cases, multiply by half. They both mean the same thing. And then we have the amplitude. The amplitude is the height of the graph from the midline, either above or below. All right. And in order to calculate the amplitude, we would subtract the output values for maximum and minimum, and then multiply it by a half or divide by 2. But when we're figuring out the amplitude, it's always in a positive values. If you take, since the difference is in an absolute value symbol. All right. And then we have the last term, which is the period. So the period of the graph is the horizontal length of one complete cycle. And when I say cycle, I mean the repetition of the pattern. So when the question is asking what is a period of the graph, we just look at what degree. We look at what degree is the graph going to start repeating the pattern. All right. So we're going to identify those 3 characteristics along with the domain and range for sine and for cosine. So let's start off with sine. All right. So the first thing I'm going to do is I'm going to identify the midline. All right. So I'm going to identify the midline. All right. So with identifying the midline, for some, you may be able to figure out where the midline is at right away by just looking at the graph. But for those who can't, let's go ahead and try to calculate. So all we need to do is we need to figure out the output values from my maximum and my minimum point. And since we labeled it out, we see that the maximum point is 90. We have 90, 1. So I'm just going to take my output value for that point, which is 1, add it to the minimum output of the minimum point, which is -1. All right. And then I get 0. And if I divide it by 2, I still get 0. So my midline is that y equals to 0. So my midline is on the x-axis. All right. And if we take a look, we see we have 3 points on the midline. All right. So now let's go ahead and figure out the amplitude. So for the midline, we added the outputs for maximum and minimum. So for amplitude, we're going to subtract it. All right. So we have 1 minus -1. We get 2. And then we divide it by 2 or multiply by half. We get 1. So my amplitude is going to be 1 unit. Now remember, the definition for amplitude is the height of the graph from the midline, either above the midline or below the midline, which is 1 unit. All right. And then we need to identify the period of the graph. All right. So we need to figure out at what point does the graph start to repeat. And if we take a look, we see that if we start over here, we're at 0, 0, which is the point that's on the midline. And then we go from the mid to the max, then back to the mid, to the min, then back to the mid. And then once we reach here, that's when the graph will start to repeat itself. So if we were to further graph 360, the graph would increase up until the maximum point, which would be at 1. All right, so the period of the graph would be 360 degrees or 2 pi. All right. So to figure out the period for any sine or cosine, we just take a look at the 5 points and see the characteristics. We're at mid, max, mid, min, mid. All right? And then after that third mid, that's when the pattern starts to repeat, only for sine. All right? So then let's identify the domain and range for this graph. So I have my domain. So the domain for this graph, if you take a look, we're looking at the right side of the x-axis, which are positive values. All right. If we were to graph on the left side, we would get a graph behavior on the right side. So in other words, if I were to plug in negative values in my function, I would actually get output values. All right. So I could actually have both positive and negative values. So my domain for this graph would be all real numbers. All right. And then now I just need to figure out my range. So I have my domain and my range. All right, so if we take a look at the range, meaning the y values, we see we're only in between two y values, which are +1 and -1. So my range would be -1 is less than or equal to y, which is also less than or equal to 1. All right, so for my domain for this graph would be all real numbers, and the range for this graph would be this inequality statement. All right, so we were able to identify the characteristics for sine. Now, for cosine, even though the two graphs look a little bit different from each other, their characteristics might be the same thing. All right, so let's go ahead and see if they are the same. So if I were to calculate my midline for this graph, we see at the midline, I have my two maximum points, and I only just need to use one of them. So for my max, I have 1 as the output, and then for the minimum, my output is -1. So if I were to do the calculations for the midline, I have 1 plus -1, I get 0. Divide by 2, I still get 0. So what do you know? The midline for cosine is the same midline that was for sine. So I have y equals to 0 as the midline. So the midline is still on the x-axis, same thing as the sine. All right, so I have my midline, which is y equals to 0. So now I'm going to figure out the amplitude. All right, so for the amplitude, I do the similar calculations. My max, we have +1, subtracted by the min, which is a -1. I get 2, divide that by 2, I end up with 1. So my amplitude for cosine of x is 1 unit. All right, so my amplitude is 1 unit from the midline to either the maximum or the minimum point. It's 1 unit. All right, so now we're going to go ahead and figure out the period of the graph. All right, so for the period of the graph, if you take a look, we're starting off with 0, 1, and then which is the maximum point. So we go from max to mid to the point that's on the midline. So we have max to mid to minimum point. So max, mid, min, then back up to mid, then we're back up to max. So we're back up, so at 360, we're back in the same spot that we started. So the period for cosine of x would be 360 degrees or 2 pi in radians, all right? And then for the domain and range, it's the same exact thing as sine of x. So my domain is still all real numbers. And then the range would be -1 is less than or equal to y, which is also less than or equal to 1. All right? So we were able to identify the 5 characteristics for sine of x and cosine of x, and they're both the same characteristics. All right?